you. In this lecture we will find the size of angle X in two different methods. In the drawing we have a quadrilateral SRPQ. We know that angle SRP equals to 65 degrees, and we also know that angle PRQ equals to 50 degrees, and we know that side PR equals to side QS, and we want to find out the value of angle PSQ or angle X, this angle. Okay, so we will start with the first method, and we will do a construction. Actually, we will extend QR by a straight line, and then from point S from point S we will draw perpendicular to the extended QR. So this angle will be a right angle. It equals to 90 degrees, and we will define this point, the touching point between the perpendicular to the extended QR, as point N, and in the next step we will draw another perpendicular from point S to PR. So this angle is a right angle, it equals to 90 degrees. This angle also equals to 90 degrees, and we will define the touching point between the perpendicular to side PR as point M, and actually after we extended QR by a straight line, we have this angle. We will calculate the size of this angle. We will define this angle as angle Z, and we know that actually QN is a straight line, and the sum of the angles on a straight line equals to 180 degrees. The sum of the angles at point R, at this side of point R, equals to 180 degrees. That is to say 50 degrees plus 65 degrees plus the size of angle Z in total must be equal to 180 degrees, according to the rule that along a straight line, if we look only at one side along a straight line, the sum of the angles is equal to 180 degrees. Okay, so 50 degrees plus 65 degrees plus the size of angle Z must be equal to 180 degrees. So we will subtract 50 degrees from this equality, and we will get that 65 degrees plus the size of angle Z equals to 180 degrees minus 50 degrees is 130 degrees. Then we will subtract 65 degrees from this equality, and we will get that angle Z equals to 130 degrees minus 65 degrees is 65 degrees. So we found that the size of angle Z is actually 65 degrees. And actually, in the next step, we will focus on the right triangle SMR, and the right triangle SNR. And we will actually prove that those two right triangles can go into each other. So first of all, we have common side. SR is a common side, it belongs to both triangles, so we can write down that SR equals to SR. It's a common side that belongs to both triangles. Again, SR, side SR, this side SR belongs to both triangles. It is a common side. So SR equal to SR. And we also know that angle SMR, this angle, is a right angle, and it actually equals to this angle SNR, that is also a right angle, and they are both equal to 90 degrees. So angle SMR equals to angle SNR, and they are both equal to 90 degrees. And we also know that those two angles are also equal to each other, and they are both equal to 65 degrees. That is to say, angle MRS equals to angle NRS, and they are both equals to 65 degrees. And actually we know that the sum of the angles in any triangle equals to 180 degrees. We have two angles that are equal to each other in triangles SMR and triangles SNR. So the third angle, that is to say angle MSR or angle NSR, will be equal to 180 degrees minus the sum of two other angles, minus 90 degrees plus 65 degrees. So 180 degrees, 90 degrees plus 65 degrees is actually 155 degrees, and 180 degrees minus 155 degrees is 25 degrees. So we actually found out that angle MSR equals to angle NSR, and they are both equal to 25 degrees, because of the fact that we have two angles, that one angle is a right angle and the other angle that equals to 65 degrees, and in order to complete the sum of the angles in those two angles to 180 degrees, the third angle, that is to say angle MSR or angle NSR, must be equal to 25 degrees in order to complete the sum of the angles in those two right angles to 180 degrees. So we actually found out that all three angles of the right triangle SMR are equal to all three angles of the right triangle SNR, and we also found out that they have one side that is the common side. It belongs to both triangles. SR belongs to both triangles. So we actually proved that triangle SNR is congruent to triangle SMR, triangle SNR congruent. This is the sign of congruent to triangle SMR according to angle side angle rule. So I read it again. Triangle SNR congruent to triangle SMR according to angle side angle rule. So what is angle side angle rule? Actually, if you prove that two angles and the side that attach to those two angles in one triangle are correspondingly equal to two angles in the side that attach to those two angles in another triangle, then you actually proved that those two triangles can congruent to each other according to angle side angle rule. And we proved that in our drawing, we proved that two angles and the angle that attached to those two angles, that is to say, and the side that attached to those two angles, that is to say, side SR in one triangle, are equal to two angles, and the side that attach to those two angles, that is to say SR, in the other triangle. Therefore, we proved that those two triangles can congruent to each other according to angle side angle rule. Okay? And from the fact that the green triangle SMR, is congruent to the blue triangle SNR, we can conclude that SM, side SM, equals to side SN. SM equals to SN according to the rule that says that corresponding sides in congruent triangles are equal to each other. The green triangle congruent to the blue triangle, therefore the two corresponding sides, that is to say SM and SN, will be equal to each other. Okay, in the next step we will focus on the right triangle SMP, and the other right triangle SNP, this right triangle SNP. and we will actually prove that those two right triangles can go into each other. Okay, so first of all, we proved just right now that Sm equals to Sn. Okay, Sm equals to Sn. That is what we have already proved just right now. Sm equals to Sn, and it is given us in the question that Sp equals to Sq. Sp equals to Sq. So if we define Sp as y, then Sq will be also equal to y. So Sp equals to Sq equals to y. Both those two sides are equal to y. Again, it is given us in the question that those two sides are equal to each other. And actually, we will prove that side PM of the right triangle SMQ is equal to side NQ of the right triangle SNQ. Okay, we will prove it now. Actually, we know that triangle SMQ is a right triangle, therefore we can use the Pythagorean theorem in order to find out the value of MP or PM. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, so that is to say PM square plus SM square will be equal to SP square. That is according to the Pythagorean theorem. Okay, according to the Pythagorean theorem. And we will subtract Sm from this equality, or Sm square from this equality, and then we will take a root from this equality, and we will get actually that PM equals to the root of Sm square minus to the root of Sp square minus Sm square. Okay, again we subtracted from this equality Sm square, and then we took a root out of this equality, and we got that PM equals to Sp square minus Sm square. So according to the same method, we'll find out the size of NQ. Actually, according to the Pythagorean theorem, if we focus on the right triangle SNQ, we can write down that Sn square plus NQ square equal to SQ square. So here we will subtract NQ square from this equality, and then we will take a root of this equality, and we will get that Sn equals to the root of SQ square minus NQ square. Okay? So we have the values of PM and Sn. Okay? But we know that SP equals to SQ equals to 1. So SP equals to SQ and SM equals to SN. SM equals to SM equals to NQ actually. SM equals to Sn again here Sn square plus NQ square equals to SQ square. Then we have to subtract from this equality NQ square, Sn square, and we will get that NQ square, again we know that according to, if we focus on the right angle triangle SNQ, this right angle, we know that Sn square plus NQ square equals to SQ square according to the Pythagoras theorem. That is true in the right triangle SNQ. So here we will subtract from this equality Sn square, and we will get that NQ square equals to SQ square minus Sn square. Okay, here we will take a root out of this equality, and we will get that NQ equals to the root of SQ square minus Sn square. So we found out the value of NQ, and we have already found out that the value of PM equals to the root of SP square minus SM square. Okay, so we actually found out the values of NQ and PM. But we know that SP equals to SQ. Okay, SP equals to SQ. And we also know that SM equals to Sn. So actually we found out that those two expressions are equal to each other. That is to say, NQ equals to PM. NQ equals to PM. So we actually succeeded to prove that all three sides of the right triangle SNP are equal to all three sides of the right triangle SNQ. Therefore, we can conclude that the right triangle SMP congruent, that is the sign of congruent to the right triangle SNP according to side rule. Okay? So what is side rule? Side rule says that if you prove the three sides of one triangle are correspondingly equal to three sides of another triangle, then you actually proved that the two triangles congruent to each other according to side rule. And here we actually proved that three sides of the right triangle SMP are correspondingly equal to three sides of the right triangle SMP. Therefore, we actually proved the triangle SMP is congruent to triangle SMP according to side rule. Okay? So, from the fact that triangle SNP congruent to triangle SNP, we can conclude that those two angles are equal to each other. Angle SPM, this angle is equal to angle SQN. Again, I will write it down. From the fact that those two right triangles congruent to each other, we can conclude that those two angles are equal to each other. So I write it down that angle SPM is equal to angle SQN, according to the rule that corresponding angles in congruent triangles are equal to each other. Those two right triangles congruent to each other, therefore the corresponding angles will be also equal to each other. And if we define angle SPM as theta, then angle SQN will be also equal to theta because of the fact that they are equal to each other. So we found out that angle SPM is equal to angle SQN and both angles are equal to theta. Okay? So in the next step I will present you a new rule and we will implement the new rule in our drawing. The new rule is rule number 1. Rule number 1 says that if two equal angles subtend on the same segment line, if two equal angles subtend on a segment line on the same side, then the 4 points lie on a circle. So I will read rule number 1 again. Rule number 1 states that if two equal angles subtend on a segment line from the same side, then the 4 points lie on a circle. So the meaning of rule number 1 is that if we have two equal angles, that is to say those two angles are both equal to theta, therefore they are equal to each other, and they both subtend on the segment line SR. Therefore, according to rule number 1, the 4 points S, R, Q, and P lie on a circle. That is to say, we will draw a circle and the 4 points S, R, Q, and P will be located on the circle that we will draw. Okay, so we will do it now. So I will repeat on rule number 1. Rule number 1 states that if you have two equal angles, that is to say those two angles are both equal to theta, therefore they are equal to each other, and those two angles subtend on the same segment line, on segment line SR. Therefore, according to rule number 1, points S, R, Q, and P lie on a circle exactly as I drew here. As you can see, points S, R, P, and Q lie on the blue circle. Okay, that is actually the implementation of rule number 1 in our drawing, because in our drawing we have two equal angles that lie on the same segment line SR. Therefore, according to rule number 1, points S, R, P, and Q lie on a circle, as you can see. Indeed, points S, R, P, and Q lie on the blue circle, and we also have rule number 2. Rule number 2 states that peripheral angles that subtend on the same chord are equal to each other. So I write it down. Rule number 2 states that peripheral angles that subtend on the same chord are equal to each other. So I will read rule number 2 again. Rule number 2 states that peripheral angles that subtend on the same chord are equal to each other. And again, we can implement rule number 2 in our drawing, because in our drawing, as you can see from our drawing, we have two peripheral angles. This angle X that subtend on chord PQ of the circle, and we have also angle PRQ, this angle that equals to 50 degrees, and subtend also in the same chord PQ. Therefore, according to rule number 2, those two angles are equal to each other. That is to say, angle X equals to 50 degrees. Angle X equals to 50 degrees according to rule number 2. Why? Because of the fact that peripheral angle X lie on chord PQ exactly as peripheral angle PRQ that equals to 50 degrees that also lies on the same chord PQ. Therefore, those two peripheral angles that subtend on the same chord PQ will be equal to each other. That is to say, angle X equals to 50 degrees. So we found out that angle X equals to 50 degrees according to the first method. So in the next step, we will find the size of angle X according to the second method. So in the second method, we will do another construction in order to find out the value of angle X. We will extend line segment SR by a straight line, and then from point Q, we will draw perpendicular to the extended SR. Okay? So this is perpendicular, that is to say this angle equals to 90 degrees, this angle equals to 90 degrees. And we will define the touching point between the perpendicular to the extended SR as point M. And then in the next step we will extend line segment QM in such a way that the new line segment will be equal exactly to QM. Okay? So here Q dash M equals to QM according to our construction, although that they are not look like that they are equal to each other. It should be like that they should equal to each other. Then we will join together points R and Q dash by a straight line. And we will join together points S and Q dash by a straight line. So we know that Q dash M equals to QM according to our construction. Again, it doesn't look like that in our drawing, but the drawing is inaccurate, but we must draw Q dash M in such a way that it will be equal to QM. So we'll assume that Q dash M equals to QM. Okay. Okay, I will draw again. I will do it again in order to be accurate. So here we have I will repeat on the same process again. We extended SR by a straight line. Then from point Q we draw perpendicular to the extended SR. That is to say, this angle is a right angle because it is perpendicular from point Q. That is to say, this angle is 90 degrees. And then we define the touching point between the perpendicular and the extended segment line as point M. This point is point M. And then we extended QM by a straight line in such a way that Q dash M equals to QM. Q dash M equals to QM. That is according to our construction. Then we join together points R and points Q dash by a straight line. And we also join together points S and point Q dash by a straight line. Actually, we extended SR by a straight line, and SR itself is a straight line, and we extended SR by a straight line. That is to say, SM is a straight line, okay? SM is a straight line, and we know that rule that the sum of the angles on a straight line at any point equals to 180 degrees. So if we look on the lower side of the straight line SM at point R, the sum of the angles must be equal to 180 degrees. That is to say, 65 degrees plus 50 degrees plus the size of this angle, we will define it as angle Z, plus the size of angle Z must be equal to 180 degrees according to the rule that states that the sum of the angles on a straight line at any point, if we look only on one side of the straight line, must be equal to 180 degrees. That is to say, 65 degrees plus 50 degrees plus the size of angle Z must be equal to 180 degrees. Here we will subtract from this equality 50 degrees, and we will get that 65 degrees plus Z will be equal to 180 degrees minus 50 degrees is 130 degrees. Here we will subtract from this equality 65 degrees, and we will get that angle Z equals to 130 degrees minus 65 degrees is 65 degrees. So we actually found out that angle Z equals to 65 degrees. Okay, angle Z equals to 65 degrees. And what is the size of this angle? What is the size of this angle? We'll define this angle as angle L. QM is perpendicular to the extended SR to SM. Yes, QM is perpendicular to the straight line SM, therefore it is a straight line, and we extended the straight line QM, therefore QQ dash is one big straight line. And we know that the sum of the angles on a straight line at one side on a straight line at any point equals to 180 degrees. That is to say, if we look on this side of the straight line QQ dash at point M, if we look on this side of the straight line of QQ dash at point M, the sum of the angles must be equal to 180 degrees. That is to say, what we have at point M on this side of the straight line QQ dash, we have 90 degrees plus angle L must be equal to 180 degrees according to the rule that the sum of the angles on a straight line equals to 180 degrees. Here we will subtract from this equality 90 degrees and we will get that L equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle L is a right angle, that is to say it equals to 90 degrees. Okay? So both those two angles are right angles and they are both equals to 90 degrees. So in the next step we will focus on the right triangle QMR. And the right triangle Q dash MR. On those two, actually we will prove that those two right triangles can go into each other. First of all, we know that QM equals to Q dash M. That is according to our construction. We built Q dash M in such a way that it will be equal to QM. Therefore, QM equals to Q dash according to our construction. QM equals to Q dash M. That is according to our construction. Then we know that those two angles are equal to each other and they are both equal to 90 degrees. That is to say, angle QMR is equal to angle Q dash MR, and both those two angles are right angles and they are equal to 90 degrees. And actually MR is a common side, it belongs to both triangles. So we can write down that MR equals to MR. MR equals to MR as a common side that belongs to both triangles. It is a common side. So we actually proved that the right triangle QMR is congruent to the right triangle Q dash MR according to side angle side rule. So I'll write it down. Triangle QMR congruent to triangle Q dash MR according to side angle side rule. Okay, what is side angle side rule? Side angle side rule states that if you prove the two sides and the angle between them in one triangle are correspondingly equal to two sides and the angle between them of another triangle, then you actually proved that those two triangles can go into each other according to side angle side rule. And we actually proved in our drawing that those two sides and the angle between them in the right triangle Q this MR are equal to those two sides and the angle between them in the right triangle QMR. Therefore, we prove that those two triangles can go into each other according to side angle side rule. So from the fact that those two triangles can go into each other, we can conclude that QR is equals to Q dash R. QR equals to Q dash R. QR equals to Q dash R according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides will be also equal to each other. That is to say, QR is equal to Q dash R. And we also know that PS equals to SQ. So if we define PS as Y, then SQ will be also equal to Y because they are equal to each other. Okay, so those two sides are both equal to each other and are both equal to Y according to our definition. So in the next step, we will focus on the big right triangle QMS, and the other big triangle Q dash MS. Okay, and we will prove that those two right big triangles can go into each other. So we will focus on the right big triangle QMS, and the right big triangle Q dash MS. We will prove that those two right big triangles can go into each other. So first of all, we know that QM equals to Q dash M according to our construction. QM equals to Q dash M according to our construction. We also know that those two angles are equal to each other, they are both equal to 90 degrees. So we can write down that angle QMS is equal to angle Q dash MS and they are both equal to 90 degrees. Okay, we prove that this angle equals to 90 degrees and this angle equals to 90 degrees because we draw perpendicular from point Q to the extended SR. Okay, so those two angles are equal to each other and they are both equal to 90 degrees. And we also have here SM, that is a common side, it belongs to both triangles. So SM equals to SM as a common side. So again, we actually proved that the right big triangle QMS can go end to triangle Q dash MS according to side angle side rule. So what is side angle side rule? If we prove that two sides and the angle between them of one triangle are correspondingly equal to two sides and the angle between them on the other triangle, then you actually prove proved that those two triangles can go into each other according to side angle side rule, and we actually proved that two sides and the angle between them in the right big triangle QDS are equal to two sides and the angle between them in the right big triangle QMS. Therefore, we proved that those two big right triangles can go into each other according to side angle side rule. So, from the fact that those two triangles can go into each other, we can conclude that SQ equals to SQ dash. SQ equals to SQ dash. SQ equals to SQ dash according to the rule that corresponding sides in congruent triangles are equal to each other. Okay, SQ equals to SQ dash, but we know that SQ equals to Y, therefore SQ dash will be also equal to Y because of the fact that those two sides are equal to each other. Okay, so in the next step we will focus on triangles SRQ and triangle SRQ dash. Okay, so in triangle SRQ and triangle SRQ dash, we will actually prove that those two triangles can go into each other. Okay, so we'll focus on triangles SRQ and triangle SRQ dash. So, first of all, we know we have already proved that RQ equals to RQ dash. Those two sides are equal to each other. RQ equals to RQ dash according to what we have already proved. We just right now proved that SQ equals to SQ dash. SQ equals to SQ dash according to what we just have already proved. SQ equals to SQ dash, and we have here a common side that belongs to both triangles. That is to say, we can write down that SR equals to SR as a common side. SR equals to SR. It is a common side that belongs to both triangles. So actually we proved that triangle SRQ can go into triangle SRQ dash according to side rule. So I write it down. Triangle SRQ can go to triangle SRQ dash according to side rule. So what is side rule? Side rule says that if you prove that three sides of one triangle are correspondingly equal to three sides of the other triangle, then you actually proved that those two triangles can go into each other. And we actually proved that three sides of triangle SRQ, this triangle, are correspondingly equal to the three sides of triangle SRQ dash. Therefore, we proved that those two triangles can go into each other according to side rule. So, from the fact that those two triangles can go into each other, we can conclude that those two angles are equal to each other. Okay, angle SQR is equal to angle SQ dash R. Angle SQ dash R. Okay, this angle is equal to this angle, and if we define angle SQR as theta, then angle SQ dash R will be also equal to theta. Okay, so in the next step we will prove, okay, so angle SQR equals to angle SQ dash R, and they are both equal to theta. So in the next step we will prove that line segment PQ dash is a straight line. Okay, line segment PQ dash is a straight line. We'll prove it. Actually, but before that, we have already proved that triangle RQM, the right triangle RQM or RMQ, congruent to triangle RMQ dash. We have already proved that those two triangles congruent to each other. Therefore, those two angles will be equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. And because of the fact that this angle equals to 65 degrees, this angle will be also equal to 65 degrees. Okay, so now we will prove that line segment PQ dash is a straight line. Okay, so how can we prove that line segment PQ dash is a straight line? It is very simple. We will check the size of angle PRQ dash. We will check the size of angle PRQ dash, and if the size of angle PRQ dash is 180 degrees, then we can conclude that PRQ dash is a straight line. That is to say, PQ dash is a straight line. So, what is the size of angle PRQ dash? The size of angle PRQ dash is equal to 50 degrees plus 65 degrees plus 65 degrees. Okay, the size of angle PRQ dash, this angle is 50 degrees plus 65 degrees plus 65 degrees. 65 degrees plus 65 degrees is 130 degrees, and 130 degrees plus 50 degrees is 180 degrees. So we actually proved that angle PRQ equals to 180 degrees. PRQ dash, angle PRQ dash equals to 180 degrees. Okay, that is to say, angle PRQ dash is a straight line. So PRQ dash is a straight line. Okay, PRQ dash is a straight line. That is to say, PQ dash is a straight line. Okay, so we actually proved that PQ dash is a straight line. And because of the fact that PQ dash is a straight line, we can conclude that the shape PSQ dash is a triangle. The shape PSQ dash is a triangle so in triangle PSQ dash we know that side PS equals to side PQ dash. Side PS equals to side PQ dash. Those two sides are equal to each other. And we have the rule that states that in front of equal sides in the triangle, there are equal sides. In front of equal sides in the triangle, there are equal angles. So in front, those two equal sides that both equal to y, there are equal angles. So which angles we have in front of these equal sides? Those two angles. That is to say, according to the rule that I stated, those two angles are equal to each other. So we know that this angle equals to theta. And those angles are equal to each other. So if this angle is equal to theta, then this angle must be also equal to theta because of the fact that those two angles are equal to each other. So we found out that angle SPQ dash equals to theta. So from now on, from this stage, we'll continue according to method 1. In method 1, we used rule number 1 that states that if you have two equal angles that subtend on the same segment line, then you can put the 4 points, those 4 points SR, Q and P lie on a circle. Again, we have here two equal angles that both equal to theta and they are both lie on the same segment line SR. Therefore, according to rule number 1 that I mentioned in rule number 1, the 4 points SR, Q and P lie on a circle. So I will draw a circle and points SR, Q and P will lie on the circle that I will draw. That is true according to rule number 1. Okay. So I will repeat on rule number 1 again. According to rule number 1, if you have two equal angles that subtend on the same segment line, then you can put the 4 points SR, P and Q on a circle. So here we have two equal angles, both equal to theta, and they lie on the same segment line SR. Therefore, according to rule number 1, we can put points SR, P and Q on a circle. As I've already drawn, we have points SR, P and Q on the red circle. So that is true according to rule number 1. This drawing is the implementation of rule number 1 in our drawing. Okay, so we have also rule number 2 that states that chords, peripheral angles that lie on the same chords are equal to each other. So here we have two peripheral angles, peripheral angle X and peripheral angle PRQ, that equal to 50 degrees. Those two peripheral angles lie on the same chord PQ. Therefore, according to rule number 2 that I mentioned in method 1, those two peripheral angles are equal to each other. That is to say, X equals to 50 degrees. X equals to 50 degrees according to rule number 2. Again, peripheral angle X lie on chord PQ, and angle PRQ that equals to 50 degrees lie or subtend on chord PQ, and peripheral angle X subtend on the same chord PQ. And according to rule number 2, if you have two peripheral angles that subtend on the same chord, they are equal to each other. That is to say, those two peripheral angles that subtend on the same chord are equal to each other. That is to say, X equals to 50 degrees. So we found out according to method 2 that X equals to 50 degrees, as we have already found out according to method 1. So in the next step I will summarize the lecture. Actually, we wanted to find out the value of angle X, and we found the value of angle X in two different methods. In the first method, in order to find out the value of angle X, we extended QR, and then from point S we drew perpendicular to the extended QR. That is to say, SN is a right angle, and then from point S we drew perpendicular to PR. That is to say, SM equals to 90 degrees. This angle is 90 degrees, and this angle is also 90 degrees. Then, after we extended QR by straight line, we calculated the size of this angle according to the rule that the sum of the angles on a straight line equals to 180 degrees. So here we have 50 degrees plus 65 degrees. So this angle must be equal also to 65 degrees in order to complete the sum of the angles on the straight line QR at point M to 180 degrees. So this angle equals to 65 degrees. So we have two angles that they are both equal to 65 degrees. Okay, and then we actually proved that the green triangle can went to the blue triangle according to, first of all, we know that SR is a common side, it belongs to both triangles, so SR equals to SR. Then we know that those two angles are equal to each other and they are both right angles, they are equal to 90 degrees, and those two angles are also equal to each other and they are both equal to 65 degrees. So if we have two angles in a triangle that one of them is 65 degrees and the other one is 90 degrees, the third angle must be equal to 25 degrees in order to complete the sum of the angles on the triangle to 180 degrees. So according to that rule, actually those two angles are both equal to 25 degrees and therefore they are actually equal to each other. Okay, so we actually proved that the green triangle can went to the blue triangle according to side angle rule. We have two angles in the green triangle. Actually, all the angles of the green triangle can went to each other, and especially we have two angles in the green triangle and the common side that correspondingly equal to two angles in the blue triangle and the common side SR. Therefore, the green triangle can went to the blue triangle according to angle side angle rule. From the fact that the green triangle can went to the blue triangle, we can conclude that SM equals to SN. Then we actually proved that the right triangle SMP can went to the right triangle SNQ. First of all, we proved that SM equals to SN. Then we know, according to what is given us in the question, that SP equals to SQ. And then we actually proved that PM equals to NQ. So why PM equals to NQ? Because PM equals to the root of SP square minus SM square, according to the Pythagoras theorem. Because of the fact that triangle SMP is a right triangle, we can implement the Pythagoras theorem on the right triangle SMP. Therefore, PM equals to the root of SP square minus SM square. And SN equals, because SNQ is a right triangle, according to the Pythagoras theorem, SN equals to the root of SQ square minus NQ square. So, but we know that SP equals to QS according to what is given us in the question, and we also know that MS equals to NQ. Actually here, actually we found that NQ equals to the root of SQ square minus SN square, and PM equals to SP square minus SM square. That is according to the Pythagoras theorem, because we have both two triangles are right triangles, and these equalities, we derive them according to Pythagoras theorem. Okay, but we know that SQ equals to SP according to what is given us in the question, and NS equals to MS, NS or SN equals to SM according to what we have already proved. Therefore, those two expressions are equal to each other. That is to say, NQ equals to PM. Therefore, we proved that the right triangle SMP can went to the right triangle SNQ according to side rule. So what is side rule? Side rule states that if you prove that all the sides of one triangle are correspondingly equal to all the sides of another triangle, you actually proved that those two triangles can go into each other according to side rule. Okay, and we proved the three sides of triangle S and P corresponding equal to three sides of the right triangle S and Q. Therefore, we prove that those two right triangles can go into each other according to side rule. Okay? From the fact that those two right triangles can go into each other, we can conclude that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. So if this angle is theta, this angle will be also equal to theta because of the fact that those two angles are equal to each other. And then I presented to you rule number one. Rule number one states that if two equal angles subtend on a segment line on the same side, then the 4 points lie on a circle. So rule number one states that if you have two equal angles, like in this drawing we have two equal angles that are both equal to theta, as you can see from the drawing, and they subtend on the same segment line SR. Therefore, according to rule number one, points S, R, Q, and P lie on a circle. Okay, points S, R, P, and Q lie on a circle, on the blue circle, because of the fact that those two equal angles lie on the same segment line. Points S, R, P, and Q lie on the blue circle. Okay, this is the implementation of rule number one in our drawing. So, from the drawing, we can see that we have two peripheral angles, that is to say peripheral angle X and peripheral angle PRQ that equals to 50 degrees, that they both subtend on the same chord PQ. Therefore, according to rule number two, they are equal to each other, that is to say X equals to 50 degrees. Okay, X equals to 50 degrees. That is according to method number one. Then we proved that we actually found out the value of angle X according to the second method. According to the second method, we actually did another construction. We extended SR till point M, and then from point Q we drew perpendicular to the extended SR, that is to say this angle is 90 degrees, and then we extended QM in such a way that Q dash M will be equal to QM. Again, Q dash M equals to QM according to our construction. Then we join together points R and Q dash by a straight line, and we join together points S and Q dash by a straight line. Then, after we extended line segment SR, we have here this angle. We know that SM is a straight line, and the sum of the angles on a straight line equals to 180 degrees. Therefore, in order to complete the sum of the angles on the straight line on the lower side at point R to 180 degrees, this angle must be equal to 65 degrees in order to complete the sum of the angles at point R to 180 degrees. So this angle equals to 65 degrees. Then we focused on the right triangle Q, and actually we proved that this angle equals to 90 degrees because of the fact that Q dash is a straight line, and we have here 90 degrees. So here this angle QM R must be equal also to 90 degrees in order to complete the sum of the angles on the straight line QQ dash at point M to 180 degrees. So this angle also equals to 90 degrees. Then we proved that the right triangle QMR congruent to the right triangle Q dash MR. Why? Because we have, first of all, QM equals to Q dash M according to our construction. Those two angles are both right angles, therefore they are equal to each other. And RM is a common side, so RM equals to RM. So we prove that those two triangles can go into each other according to side angle side rule. Then, so from the fact that those two triangles can go into each other, we can conclude that QR equals to Q dash R. And if we define so QR equals to Q dash R, and we also can conclude that those two angles are equal to each other, so this angle equals to 65 degrees, therefore this angle also equals to 65 degrees. Then we focused on the right big triangle QMS and the right big triangle Q dash MS, and we proved that those two triangles can go into each other. Actually, we know that QM equals to Q dash M according to our construction. Those two angles equals to each other, they are both equal to 90 degrees. And SM equals to SM is a common side. It is a common side, therefore we proved that those two big right triangles are equal, can go into each other according to side angle side rule. From the fact that those two triangles can go into each other, we will conclude that SQ equals to SQ dash according to the rule that corresponding sides in congruent triangles are equal to each other. So we know that SQ equals to Y, therefore SQ dash will be also equal to Y because of the fact that those two sides are equal to each other. Okay, and then we focused on triangle SRQ and on triangle SRQ dash, and we proved that those two triangles can go into each other. Why? First of all, we know that RQ equals to RQ dash, we have already proved it. We also know that SQ equals to SQ dash, that is what we have already proved just right now. SQ equals to SQ dash, and SR is a common side, it belongs to both triangles, so SR equals to SR. So we actually proved that those triangles can go into each other according to side rule. From the fact that those two triangles can go into each other, we can conclude that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. So if this angle is theta, this angle will be also equal to theta because of the fact that those two angles are equal to each other. Okay, then we actually proved that PQ dash is a straight line. How we proved that PQ dash is a straight line? Because of the fact that angle PRQ dash equals to 180 degrees. Why angle PRQ dash equals to 180 degrees? Because it is actually equals to 50 degrees plus 65 degrees plus 65 degrees. That is actually in total 180 degrees. From the fact that angle PRQ is 180 degrees, we can conclude that PRQ is a straight line. That is to say, from the fact that PRQ dash equals to 180 degrees, we will conclude that PRQ dash is a straight line. If PRQ dash is a straight line, then PQ dash is a straight line. So PQ dash is a straight line. Therefore, because of the fact that PQ dash is a straight line, then PQ dash S is a triangle. And in triangle PSQ dash, we know that PS equals to PQ dash, and we have the rule that in front of equal sides in the triangle there are equal angles. So in front those two sides that are equal to each other, we have two equal angles. Those two angles are equal to each other, and this angle equals to theta. And if this angle equals to theta and those two angles are equal to each other, this angle will be also equal to theta. And from this point, we continue according to method 1. In method 1, we actually presented rule number 1. It states that if you have two angles that subtend on the same segment line on the same side, the 4 points S, R, P, and Q lie on a circle. So we have here two equal angles. They are both equal to theta, and they lie they subtend on the same segment line SR from the same side. Therefore, according to rule number 1, points S, R, P, and Q lie on a circle. 3 points S, R, P, and Q lie on a circle. And we have rule number 2, that peripheral angles that lie on that subtend on the same chord are equal to each other. Angle X lie on chord PQ, and angle PRQ that equals to 50 degrees also lie on the same chord PQ, therefore they are equal to each other. That is to say, X equals to 50 degrees according to rule number 2. So we found out that the value of X equals to 50 degrees also according to rule number 2. Okay, thank you very much.